Transition elements. Okay, so you can look at your periodic table and you can look at the first transition series and write down the symbols or the names of the first 10 transition elements. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay, now you'll remember that they were special. They were special because their valency was a bit strange. They didn't fall into the classic, the group that they're in tells us how many electrons are in the outer shell. It's a little bit more complex than that. So don't worry too much about the electronic configuration of the transition elements because that comes later at A level. So the characteristics of the transition metals. Let's have a little look at these. They form colored compounds, as you can appreciate in the picture. They typically form colored compounds, and if they're soluble, they'll form colored solutions. Okay, so some of these here, I mean, you can imagine maybe the blue is copper, 2 ions, the green could be nickel, 2 ions. These oranges and yellows can be chromium. This is some kind of manganate, that might be manganate 7. This might be manganate 2. Okay, you don't need to know that, but it's just good to have a few names up your sleeves. We've seen some of these before. We've seen manganate 7, and you've seen copper sulfate solution. Other ones you might have come across dichromate. They make very good catalysts. Now they make good catalysts for 2 reasons. They're good at absorbing things onto them, and also they're good at catalyzing reactions because of their variable valency. So they're often involved in redox reactions. They're often involved in electrons being lost or gained. So they have a variable valency. This means they've got variable oxidation states. Now, the classics at IGCSE are copper 1 and copper 2 ions, Cu plus and Cu2 plus. And here you can see I've written down 2 examples of formulae that these ions may form. So this would be copper 1 oxide and this is copper 2 oxide. The other example that you need to know is iron 2 and iron 3, Fe2 plus and Fe3 plus ions. And let's look at the oxides. You have iron 2 oxide and iron 3 oxide. Some examples for you. What else can we say about transition elements? They tend to be hard, dense, high melting point metals. They're relatively unreactive. They might seem reactive, but generally when you have them, they don't immediately react with what's around them, with water or with oxygen, not like potassium or sodium or calcium. And typically they're used to make alloys. Now let's have a look at a few of these photographs. We've got an aeroplane engine, so that's going to be something to do with alloys of the transition elements, potentially with iron and maybe even with aluminium, a mixture of those metals. They're unreactive. Well, they do exist. If you purify them, you can have them as their metallic form. They might form some kind of surface covering, but generally they don't react very fast. They're hard and dense, high melting point metals. Well, look at tungsten. Tungsten is 19.25 grams per centimeter cubed density, which is 20 times more dense than water. That's tungsten. Wolfram, which is a German word, tungsten. It also has a very high melting point, look, 3,695 Kelvin. So if you take away 273, you'll get that in degrees Celsius, so a very high melting point. And typically they're used to make things like drill bits. They're very hard, they don't melt. They can be quite brittle. If you drop one of these, it can break, but they're very good at drilling. Now let's have a little look at transition elements as catalysts. This is an equation, a reaction you might have come across before. The decomposition of hydrogen peroxide. It forms water and oxygen. And this is how we produce oxygen in the laboratory if we need it. The catalyst, the classic catalyst for this reaction is manganese 4 oxide, MnO2. One of the things that can come up sometimes at IGCSE is they get you to explain how you could know this was a catalyst. And what you do is you measure a specific amount of the manganese 4 oxide, it's a black powder, before the experiment, do the experiment, then evaporate off the water or filter the manganese 4 oxide, dry it on the filter paper, find its mass, and then you can show that it hasn't actually been used up in the reaction. You can also see other reactions where transition elements are acting as catalysts. There's a really good video here that you can have a look at your own time. Let's have a look at another specific reaction, chlorine with iron 2 sulfate. Now we saw in the last section that chlorine is a very good oxidizing agent. So iron 2 ions will be oxidized here to iron 3 ions. The chlorine is acting as an oxidizing agent. It's taking the electrons, or taking an electron from the iron to make Fe3+. It oxidizes the Fe2+. If we have to balance the electrons, then we have to multiply the second equation by 2. There you go. And then when we add them together, that's the overall equation. 1 molecule of chlorine oxidizes 2 iron 2 ions to form 2 iron 3 ions and some chloride ions. It's a good example. And what would you see in this reaction? Well, you've got a light green gas in a pale green solution here. And what happens is iron 3 is formed, so the solution turns brown. Okay. Right, have a go at the questions on the pages indicated.